what's up, guys? Welcome back to my channel and glad to see all of you guys here today. So in the past videos, we have learned ideal gas law and how to look up properties by looking up thermodynamic property table. And also we have learned vapor pressure curve to determine it's going to be a liquid phase or gas phase. And also the procedure of dealing with properties if they are liquid or superheated vapor. And also we have learned vapor dome and also the quality if it's a mixture. And the quality is V minus V sub F divided by V sub Fg. So today we are going to use all the knowledge and the skills that we have learned to solve the problem to determine the phase and the specific volume. So let's get it started. Okay, so the problem says for each problem, fill in the missing thermodynamic property for R134A. Okay, so it's no longer H2O, so it's R134A. So you are going to look up the table A11, 12, and 13. So no longer A4, A5, A6, because the substance is R134A. And also says if the state lies on the vapor curve, then give the range of possible specific volumes. And also quality of 0 or 1 indicates the phase is the mixture and saturated. In particular, if it's 1, then it's saturated 100% of gas. And if it's 0, it's going to be saturated 100% of liquid. So let's take a look at one by one. So the first one, it tells us the temperature and the pressure. So we probably can start off vapor pressure curve. So we could use either property. So let's try the temperatures first. So we are going to draw a vapor pressure curve. P is at the top and T is at the bottom, and draw a curve. Then if we start off the temperature, then from table A11, when the temperature is minus 12 degrees, the saturated pressure is 185. And our pressure is at 320, so we are above, so we are in liquid phase. If it's a liquid phase, we are going to use incompressible assumption. So the property is only be depending on the temperature and won't be depending on the pressure anymore. So we are going to use table A11 again because it's only depending on the temperature. So when the temperature is negative 12 degrees C, the specific volume equals to V sub F because we are in liquid phase. Then this is the answer. Then let's take a look at the second one. So we know the temperature and the specific volume. So the only thing we can try is A11 because we only know the temperature. So from table A11, when the temperature is 30 degrees C, we can try the specific volume for saturated liquid and for the saturated gas. And it turns out to be our specific volume is in between. So we are the mixture phase. So if it's the mixture phase, then it's saturated. So our pressure is going to be the saturated pressure. Then we are going to calculate quality. So quality is V minus V sub F divided by V sub Fg. Then put the numbers in. This is the quality. And it turns out to be 22% is in gas phase. Next one, let's take a look at the third one. So we know the pressure and the phase. Wow, so X equals to 1 means it's 100% saturated gas. Wow, then the problem is easier. So since we know the pressure, so let's try table A12. it's saturated. So the temperature is the saturated temperature, which is 18.73 degrees C, and the specific volume is Vg because it's saturated vapor, and it's this number here. Then the last one, we know the temperature and the pressure, so we still can use vapor pressure curve. So let's still try using table A11 with the temperature 60 degrees C. With the vapor pressure curve, P is at the top, P is at the bottom. Then when the temperature is 60 degrees C from table A11, the pressure is 1683, but our pressure is at 600. So we are below, so we are in gas phase. So it's 0.6 megapascal. So it's kind of high. So we probably want to use the table instead of an ideal gas law. So from table A13, when the pressure is 0.6 megapascal and the temperature is 60 degrees, the specific volume is this number. And in this case, if you did use ideal gas law, is about this number. So it's about 0.8% off. So not too bad in this case. However, when the pressure is high, we recommend you to use the property table. And this is the solution for all those 4 problems. So X equals to 1 means it's a saturated gas. But if it's a superheated gas, then you cannot write as X equals to 1. So X equals to 1 is only for saturated gas. If it's superheated, then you write as gas. And a similar thing, if it's not saturated liquid, then you write it as liquid. You write X equals to 0 only if it's saturated liquid. Did you get it? All right. And we also have some practice problems for you to practice. Then you can try to solve those problems, see if you can get the right answer here. All right, this is all we have for today's part. Thanks for watching. See you next time. Bye.